India is a developing country with more than 1 billion citizens, and it faces many challenges ranging from social to sustainable issues such as overcrowding, urban pollution, and power shortages. Kolkata is the city we focused our research on, and it suffers from the majority of these problems. If no action is taken to help combat these problems, the people of the city will continue to suffer. There are multiple provinces and different levels of income within India, and specifically for our challenge, we decided to focus on the middle income families in the region of Gobindapur, which is in Kolkata in West Bengal. During the summer, cooling appliances and other essential household appliances are in the highest demand, which means that energy shortages and blackouts are more frequent. In addition, in the monsoon season, infrastructures are often crippled and electricity cannot be supplied to the apartments connected to the grid. The major challenge of the middle-income families in Gobindapur is that they do not have consistent and reliable sources of energy during the time of most demand. Most of the cluster apartment blocks rely completely on the regional electrical grid. Furthermore, pollution that exists in densely populated areas of Kolkata just adds on to the decrease in the quality of life when blackouts occur. The aim of our team is to find a way to make energy easily accessible and reliable to the cluster apartments so they do not have to rely on electrical grids during failures. Also, the solution will utilize a form of renewable technology and green energy to lower the pollution levels in Kolkata. Our group will be designing a microgrid using solar energy for an apartment block in Gobindapur. This energy will be used to power cooling appliances when blackouts happen, which is a necessity during the summer. Once implemented, the microgrid will be able to sustain itself and will require little maintenance while also providing green energy in the long run. In the course of our project, we have looked into various forms of renewable energy to provide for our microgrid. In general, we looked mainly into solar energy, but also anaerobic digestion. Solar power can be harvested into photovoltaic cells, which in turn convert light energy into electrical energy. Anaerobic digestion is similar to a fermentation process, where methane gas is obtained from biogenic fuels when they are put in an environment lacking oxygen. In addition, we also focused on the use of fabrics. Fabrics serve as a barrier to sunlight, shading the apartments and meaning that less energy is used on cooling them. After assessing our options within our group, we agreed on solar energy being our primary source for renewable energy, as it is the most easy to obtain. In this project, we intend to get 50% of our funding from grants, which we are going to apply for with the United Nations Environment Programme and the Indian Solar Loan Programme. Next, for the other 50%, we are looking at crowdfunding for people who support the same cause as us. Our group will use dome solar panels on the top roof. These dome panels have prolonged exposure to sunlight due to their shape. Fabrics will also aid our project and be used to decrease sun rays received by the apartment. A solar inverter will produce DC and AC currents, one of which will be used to power the cooling appliances and the other which will be used to store energy in a battery for use during the blackout. Cooling appliances are therefore now independent of the main grid. As well as this, every solar grid will also be equipped with a smart meter, which shows the amount of energy being used and its price. Customers will be charged accordingly until the initial costs of the solar implementation are repaid. This means that the whole system has the chance to be completely cost-free within a few years.